camera is running, okay? Camera's running, guys. It's happening. So, yesterday we learned, we had the first lecture on exponent rules. We learned a bunch of rules. Let's first of all review what we learned. We learned, let me be sure this all works. Okay.
Should we write this down?
You don't have to, because you already have it in your notes. But I'm just reminding you what we did. We learned that a to the n times a to the m is equal to a to the n plus m. Remember that? So, same bases with exponents multiplied together. When you multiply them, you add the exponents, right? Okay. Another one we learned was that if we had a times b to the n power, that equals a to the n times b to the n. Isn't that what we learned? We learned that, right? That was that one we just did. 4x squared was 16x squared, right? Because you have to square the a and you have to square the b. You have to square whatever number that is and whatever number that is, regardless of whether they're numbers or variables, right? A number is the same thing. Like an example of this would be 6b, well, yeah, 6b. 6 looks like a b. 6, I'll do a different one. 6x to the, squared is equal to 6 squared x squared, which is equal to 36x squared, right? So you remember that. So that was another one we learned. Third one that we learned was this weird one that said if you have a to the negative n, that would be the same as writing 1 over a to the positive n. Okay? Which is weird, and we'll talk about that maybe today, depending on how much time we have. But there's actually a reverse of this as well. That sometimes it's written like this: 1 over a to the negative n is equal to, what do you think?
A to the positive n?
A to the positive n, right? That goes upstairs, numerator, 1's not down the denominator. You don't need a 1 anymore. You don't need the denominator if 1's the denominator. So it's just a to the positive n. Okay? So, okay. So now we're going to learn a couple new rules. I'm going to erase this one because it looks like that's a rule, but that's just an example of a rule. So that way we're only having our rules listed up there. Okay, another rule. Should I do that one first or second? Okay, I'll do that first. All right, it's sort of like this one. Sort of like this one. Only notice in this one there are no exponents other than 1 inside the parentheses. Do you see that? So watch this. What if I gave, let me just see how I wrote the rule. Okay, so if you have a, this is our next rule, a to the m in parentheses raised to the n power equals a to the m n. M times n. Does that make sense? M times n. Now, usually when you're multiplying things with same bases, usually you never multiply exponents, right? You're adding the exponents, right? That's what we've been doing. However, what does a parenthesis mean?
Multiplication.
Multiply, right? Does everybody know that? Parentheses means multiply. So really, this says n times m. Does that make sense? Just remember, if you have an exponent inside of parentheses, and then you have parentheses, and then you have an exponent outside the parentheses, you actually have to multiply that exponent times the other exponent. Okay? So, example.
So you're not multiplying a and n, you're only multiplying m and n?
Yes, exactly.
Oh, okay.
Right? Does that make sense? So let's look at an example. Well, I'll first use a number first, okay? So if I had 2 to the 4th power raised to the 8th power, all right? What that means is this. That means 2 to the 4th times 2 to the 4th times 2 to the 4th. Why did I use a big number? 2 to the 4th times 2 to the 4th times 2 to the 4th. Jeez Louise. Okay, 1, 2, 3, 4, 5, 6, 7
I know, it's 2
times
to the
2 to the
32nd.
4th, right? That's what that means, right? Isn't that what that means?
Yeah.
I'm raising to the 4th 8 times, I mean to the 8th power. So it's that. So I could add all these, right? 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20, 24, 28, 32, right? So that would be 2 to the 32, right? Because I'm multiplying same bases with exponents, I just add the exponents. I keep the base and add the exponents. Yes?
You could have just said 8 4 times.
True. True. But I was writing it the way this is written, right? I'm writing it the way this is written. But thank heavens for algebra to come save the day. Da-da-da! Algebra's here! And algebra is all about shortcuts, right? Shortcuts. That's what I love about algebra. I love shortcuts. I love them. So do you guys too. I know that, actually, for a fact. All right. So this is 8 times 4, or 4 times 8. All I'm doing is multiplying the exponents together. So my final answer is 2 to the 32. Now, I would much rather do it this way than this way. Wouldn't you? So easy. All right, so another example. Because sometimes I'm going to actually combine 2 rules now. Watch this. X to the 5th, y to the 6th, raised to the 11th power. So write that down in your notes. X to the 5th times x to the 6th, all in parentheses, raised to the 11th power.
And y to the 6th?
So what?
You said,
What did I say? X to the 5th,
times
y
x
to the 6th.
is
Sorry.
what you said.
Times y to the 6th. Sorry.
Oh, okay.
Sorry. Thank you. So that 11 has a parenthesis right next to it. And inside, there are other exponents. There are actually 2 exponents. So Weston, what would you do here?
So you would multiply xy to the 5th power times y to the 6th power by 11.
Okay, so what's the answer?
330?
Just west.
I'm not sure.
So you're multiplying
Wait,
this times what?
30.
No,
Wait, would be 30.
Times the exponent. You're not adding these exponents because they're the same base. They're not same
No,
bases.
I know.
So wait, Weston, what is 11 times 5?
It's 5.
Right, that's it.
Oh.
And then
that's what
y
I'm
to, now tell me the last one. What's,
Okay, that's
66.
Y, yeah.
there you go.
Okay.
Right? So you can't combine them. They're not same bases, right? So you can't add these exponents in here. You have to keep them separate. But this means, since it's next to the parenthesis, it has to affect everything inside every exponent inside the parenthesis gets multiplied. Yes? Fist to 5, you get that? All right, so real quickly, let's do another one. So x to the 10 times y to the 4 raised to the 5th power. Okay, Noah, what is it? X to the
x to the 50
Yes.
power, and y to the 20th power.
Good job. X to the 50th, y to the 20th. All right, using the same idea, what if I gave you something like this? A squared b cubed c to the 5th, d to the 8th, to the 4th power.
Killing me, Gary.
I know the answer.
Killing me.
So what would that be?
That's easy.
What would that be?
Gary.
It would be
Yes, Weston, go. A to the
it's the 8th power
8th,
times b to the 12th power,
yes?
and then over c to the 20th power, right?
C to the 5 times 4, which is 20.
Yeah, it's
And then d to the
30.
32nd power, right? Good. Right? Makes sense, right? Every exponent inside the parentheses has to be multiplied by that outside exponent. Does that make sense? Pretty clear, right?
The distributive property a little bit.
Yeah, it's very similar to the distributive property. Okay, I'm running out of time. Nate, can you just see if I get up 5 more minutes?
Yes.
It's amazing how much time things take. All right, so can I erase this? All right, so you guys are good at this rule, right? It's pretty easy. It's awesome. It's a great rule. All right, there's one more rule that I'm covering today. Just want to be sure. Okay, here we go. All right, a to the m over a to the n. Now, every fraction is a division problem. All right, before, when I did the multiply problem, I have same bases multiplied together. I added the exponents. So what if, now this is divide, right? So if I'm same bases and I'm dividing, what would you think you'd do to the exponents? Subtract, right, exactly. When you multiply them, you add them. When you divide them, you subtract. So this actually technically is this. A, same base. A is my base, so I put my base here. And it's just to the m, you start upstairs and you move yourself downstairs. So it's m, and then this big fraction line, I think that is a very big, long minus sign. Right? See that long minus sign right there? So it's a to the m minus n. No, I didn't mean to do that. Right? That's a joke. Sorry. But a m minus n, right? So it's just a to the m minus n. Easy. So if I had a,
Number.
if I have x to the 8th over x to the 4th, what would that be, Gabe?
What would that be?
X to the
4.
8th minus 4, which is x to the 4th. Good job. All right. What do I have? Henry, if I had x to the 12th over x to the 3rd, what would that be? So what would this be? Same bases. I'm dividing them.
X to 4.
No.
You're not dividing.
So the rule, this is what I want you to do. I think you sort of spaced out from this rule. The rule says, if you have same bases and you are dividing, this is every fraction is a division problem. This divided by this, right? So the answer is the same base, this exponent minus this exponent. This minus this. This minus this. This minus this. So this minus this. So what's the answer? X to the
8 power.
almost.
7. 9.
Well, yeah, 9. 9, 10, 11, 12, right? 9. X to the 9th power, exactly. So that's all that is. Now, okay, I'm going to make it a little harder on you guys. Not very hard, much harder, just a little bit. Oh shoot, I just erased the rule. All right, let's put these rules over here. A to the m to the n is equal to a to the mn. And this one was a to the m over a to the n is equal to a to the m minus n, right? All right, so good, I can get rid of that too. So what if I did this? What if I had this? X to the third over x to the seventh. All right, Rebecca, what would I get? X to the -4. Am I done?
No.
Is she done? Excuse me, is she done? No, you're not done, Rebecca. Right, we're going to put it over 1. We're going to move that downstairs. So it's 1 over x to the +4. Right? Yes? Okay. I think that's... Okay, let me just look at these problems now. Boom, boom, boom. That's fine, that's fine, that's fine, that's fine. Oh, I got to show something. What if I gave you something like this? Okay. Well, yeah, okay. So what if I gave you something like this? 5x squared over x to the 8th. All right, Graham, help me.
Yeah.
So, Graham, you're making it too hard. You're letting the 5 scare you. Really, all that says is this. 5 over 1 times x squared over x to the 8th. That's all it means, right? So the 5 just stays, right? And then you just do this part. So the answer is 5 what? 5 x to the -6. Okay. Everybody see that? All right, now everybody watch. Eyes up here, because I guarantee you if you don't watch this, you won't know it. Graham is about to show us how to convert this. Hang on a second. Graham is about to show us how to convert this to a positive exponent. We're going to put it over 1. And what are you going to circle?
The x to -6.
Why not the 5? Because the 5 is not the exponent only affects what it's next to, right? So he's going to bring that downstairs. The 5 stays upstairs, right? So the answer is 5 over x to the 6. Good job. And I think that is it. I'm going to do all I'm going to do for you. Okay, so I'm going to just give you guys the homework. That's it on the lecture.